Next, we have Miss Shannon Carey, a recent graduate with a double major in robotics engineering and psychology. She is a robotics automation engineer at HighRes BioSolutions. Feel free to share your slides now.
Hi, everyone. Thanks so much for that awesome introduction. Let me just get my screen share set up here. Lovely. Can everybody see this? Sorry, you can't all answer me, but I'm going to assume that it's a yes. So thank you again. I'm really happy to be talking to you here today. Like they said, my name is Shannon Carey. I'm a robotics automation engineer for HighRes BioSolutions. A lot of what we do, so if you hear something like, such and such a facility is doing, 40,000 COVID tests a day, we're making sure that any of those biomedical automation processes happen correctly. And that's a really wide range of things, but it's a great job and I'm really fond of it. But today I'm actually going to be talking about something different and something that many people don't see as being as technically related to robotics, but I think is really, really important if you're going to succeed as a team, and that is project management. So to start out with, project management is a massive field. It's kind of hard to summarize all of the things that you could possibly want to know in 20 minutes. It is something that people, take classes in, something that people major in, something that people spend their entire lives and careers in. And you can make a lot of money being a project manager as your job. But in our context, and for FIRST Robotics, we want to talk about three things. And that is, how do we plan a project? How do we execute those plans and make sure that they actually happen? And how do we recover from mistakes when they inevitably happen? How do we use that to our advantage and move forward? I also want to acknowledge here that I'm sure you guys have all done projects before, being students, being in middle school and high school, whether you're doing a small homework assignment or a month or two long term paper, you've had to do projects in the past. And so I think the question that comes to mind is, I haven't needed any strategies for this before. Why do I need them now, and why do I need them for FIRST? And I think what's important to note here is that when you're building a robot, the process is going to be a little bit different for a few reasons. Most importantly, the projects are harder. And when I say projects get harder, I also mean in your academic life. As you go through high school, as you go through college, you're going to have bigger and bigger projects. And while you might have been able to kind of wing it or, submit something that was okay, but not your best work in projects in the past, when you're working with a team and you're working on something really big like this, we need actual management to go into it, to make sure that we stay on track. So project management is going to help us out there. But secondarily, the projects are going to be more meaningful. And what I mean by that is, if you do something like a book report, for example, you might have learned a lot about how to write or how to analyze literature, but the events of that character's life might not be important to you every single day from then on. In robotics, you're going to have kind of a different situation, because what you learn today about how to crimp wires is going to be important for you to remember tomorrow and next week and next year. And trying to retain information in that way is going to be a little different. So we need to have strategies in mind when we go into it to make sure that we're really holding on to what we're learning and using it appropriately. So without further ado, let's talk about how we actually go through the planning process in our project. And we're going to start really simple. And by that, I mean, start by defining your goal. This sounds so silly and so straightforward, but a lot of times you might actually realize that you're not on the same page about what your goal is. So if I were to ask you as a robotics team, and I can't really ask you right now, but I hope that you think about this in your head, what is your goal as a robotics team? I think the first answer that most people come up with is, well, we probably want to build a robot. And that's fair. It's a very good answer, and I hope that you answered that you want to build a robot because that's why you're here. And that's a really important thing. But I also hope that you have other goals, and I also hope that you acknowledge that there are multiple targets in this situation, because I hope that you're also here to learn about robotics, and I hope that you're also here to have fun and have a good time. And if you start out by saying that your only goal is to build a robot, you may find at the end of the year that you've succeeded really well at that goal and not learned about robotics and not had fun. It is possible to do one without the other, so we want to acknowledge in the beginning what the big picture actually is and make sure we're on the same page. From there, we want to define tasks. So we've got this one big thing that we want to work to, but in the same way that if you were going to build a wall, you wouldn't just put a wall down. You have to layer it up brick by brick. We have to acknowledge what things need to happen in order to achieve your goals. So if you're building a robot, for example, you might say, well, there needs to be some mechanical engineering going on here. We've got to build an actual thing. And once we've got that, there's got to be electrical, we've got to wire it. And ideally, we'd like it to have some kind of a brain behind it. So we've got some programming. There's a lot of different steps. And I also hope that you take those steps and you layer them, because even each of those are fairly big points. By taking your big goal and breaking it down into smaller and smaller pieces, you can get a really good list of what needs to happen over the course of the build season. Zooming in even further, I want to talk about two really important terms. And you may or may not have heard these before, but I want to just bring home the importance of them. And those are dependencies and constraints. So we've got our big picture. We've got our series of events. What's going to be really important is how we actually put those in order and approach the process of planning our robot. A dependency is a relationship where one thing can't move forward until something else happens. So as a perfect example, I am currently I'm traveling for work. I was sent to update a system that we have at a site here in New Jersey, and I'm in a hotel for a couple weeks. And I love tea. I really like drinking tea. And so I brought a bunch of tea bags with me. And I said, great, I'm going to have my amazing tea. I'm so excited. And I got to the hotel, and there's not a tea kettle here. And it was the biggest tragedy of my whole day. But the important thing to bring home here is I can't make tea unless I have hot water. No matter how well I plan, no matter how well I outline, which I've got all these different tea bags, I have to have that dependency in place. And in the same way, when you build a robot, you might run into situations where programming can't test their autonomous mode until they have a chassis, or perhaps where two things have to happen at the same time. Like a mentor needs to be present when I'm going to use the drill press in the mechanical room, so it's important that I make sure that those happen together. Dependencies are going to define the order in which you put all those bricks and how you put them together. Constraints are the limitations we have on how we move forward. So in the same way, as much as I love tea, I'm actually relatively caffeine intolerant, and I like black tea, but I can only drink so much before it makes me feel really gross. To me, that's a limitation, and it stops me from doing certain things that I might want to do. In the same way, if you get to the end of your term and you're looking at your robot and you're saying, you know, I wish we'd gone with the other design for the shooter, you might find that it's a little late because you only have 10 days left. So time is going to be a really important constraint for you to think about. You might also find that the size of the robot, the weight of the robot, there's half a dozen different things that you want to be aware of when you're thinking about constraints for your system. So I highly recommend thinking about both of these things before you move on to the next step. At this point, we're going to talk about our timeline. So what I mean by this is planning tools are really, really helpful for us. They're going to help us outline what we're doing. And now that we've got all this random information, we want to put this into a format that makes it easy for us to understand and for other people. The timeline I have below is a project that I did that lasted probably 4 months by the end in my last term of college. And as you can see at the very bottom, what's happening is we have a bunch of different tasks. So we have engineering tasks at the very bottom. And they're broken up into these little chunks, these nice little visual, colorful lines on the bottom based on how long that task lasts. So in this case, we have to design the thing that we're going to build before we go into any of the building processes. We can't do any mechanical programming, whatever, until we've designed it. And in this case, we actually have an iterative design process, which I'll talk about in a minute, where we then go back to an analysis. We design it again, and then we go build it again. So when you're doing something like this, putting it on paper and really forcing yourself to walk through each step helps you figure out what has to happen in the whole picture so that you know how to move forward appropriately. The last thing I want to talk about is, it may be strange to think of them in this context, but your design tools such as CAD, schematics, and programming diagrams are also kind of a part of project management. They're things that you're going to use to help you plan out what you're doing later on down the line. And it's going to make it a lot easier for you if instead of just throwing bolts and nuts together, you can actually, have a plan and know what you're going into. Anytime that you have a lot of information, you want to try and organize it so that everybody's on the same page and you're not building two different asymmetrical halves of the same robot. Next, I want to talk about how to execute a project. You can have the best plan in the world, but making sure that it actually happens is a whole different skill set. So This will be brief, but I want to talk about things too because it's really important. The first is this concept of iterative design. So this may or may not be something you've heard of before, but it's super big in the engineering world. And that is the idea that design isn't something that's one and done. You're not necessarily going to design something and have it work on the first try. And in fact, you should plan for that not to be the case. This is what we often do when we're talking about prototyping a robot. We start with the planning phase. We say, how should we do the thing? What do we want to do? How is this going to work? The execution is the let's do a thing. All right, we've got it, we build it, we see what happens. And in evaluation, we say, did that thing work? And what's more than likely to happen is that we may have to go around this cycle a few times before we get a result that we're really happy with. Eventually, if we're lucky, we get to go to the conclusion and exit this loop. We say, hooray, it worked, and we get out of there. But be aware in your planning process that this is not only reasonable, but encouraged. We want there to be iterative design. We want you to take time to evaluate what happened instead of just running forward with the first thing that you get. If you remember nothing of this PowerPoint presentation, this slide is probably the biggest thing. And this is why I ended up double majoring with robotics and psychology, because I realized from my high school first experience that no matter how well you do with building a robot and planning a robot, you're not going to get much of anywhere if you don't have effective communication. I'm going to break that down into a few steps. The first actually starts with yourself. You have to be able to communicate with yourself before you can communicate with anyone else, because if you're not aware of what issues you're experiencing, if you can't put them into words, then it's going to be really hard for anyone else to read your mind. In order to do this, we want to talk about what's happening. Do you have a problem? What is the issue that you want to talk about? Just acknowledge the event that you're trying to process. Who should know about it? If you're going to communicate, you could just tell everyone. You could send out a mass email, but that's probably not the most efficient way to go forward. We also want to talk about what we need from others. If you need something to move forward with your problem, you need to be aware of that first so you can communicate it to other people. Awesome. We know where we're at. We're self-aware. When we step forward, we want to talk about the transparency. So now you have to take that information and share it. You want to share your goals, you want to discuss your problems, and you want to brainstorm solutions. Bring people in and communicate, but also listen to them. Make sure that as well as talking, you're discussing and you're hearing together. Now, the situation that I tend to see with these first couple points is, let's say that you're a programmer and you want to test out your code on the robot. You've got those first few points. You say, what's happening? I need the robot and I'm upset about it. What should I know? I know that I'm going to tell the mentors, I'm going to tell the team I need this thing. And you're transparent. You've shared your information and you say, I'm mad at you because I don't have the robot. Well, technically you've communicated fairly well. There's something that we're missing here, and that's going to be empathy, because being upset about wanting the robot doesn't actually solve the problem as much as it is technically communication. We want to take the time to respect each other's goals and acknowledge that maybe mechanical also needs time to work on the robot because it's not done yet. Maybe we also want to acknowledge that mechanical's been working really, really hard, and the reason that they don't have it ready is the part didn't ship. It wasn't out of malice, and I can almost promise you, your teammates aren't trying to sabotage you. We want to be empathetic, and we want to remove barriers instead of just putting them up. So when you're communicating, make sure that you're following each of these steps as you go through. I think if you do, things will turn out really well. The last important element is actually going to be record keeping. Anytime that you go through a process like this that you intend to know about in this feature, and this is associated with that meaningfulness aspect that we talked about earlier, we want to acknowledge any time where our expectations were different from our reality. So if we thought that our shooter was going to, knock it out of the park, be awesome, and it just didn't, we want to write down why. We want to write down that it happened and anything that we know about it so that we can solve it in this case and not do it again for the future. We also want to write down any common problems and solutions. If everybody is putting in the same part backwards, you probably don't want to have to solve the problem 15 times when each person does it. Write it down so that you can go forward. And last but not least, whether you're a rookie team, whether you're a vet, teaching guides are really, really useful, especially in high school and in middle school. You're going to have new students coming in every year, and you're going to have new people graduating every year. And that means that it's really hard to preserve that information if the only way that you're transporting it is word of mouth. So write down what you know as if you had known nothing, as if you're talking to your own freshman or 6th grade or 7th grade self and say, what would I wish I had known? On the right is a very simple example of kind of a bake sale. I ran a bake sale for a club as a part of something that I did in my senior year, and we discovered that apparently no one likes bananas nowadays. And if we'd known that, perhaps we wouldn't have bought so many bananas. But now that we've written it down, next year we can make better choices and make sure that there's more granola bars available. So that kind of thing is really useful. There's no way I would have remembered that particular fact, but now I have it written down so I don't have to. The last part is going to be talking about how to fail productively. Failing is a really negative word in the way that we always hear it. You never talk about failing, especially as a student, as a thing that you're proud of. You don't come home with an F and your parents go, oh, good, I'm so glad. But failing is actually something that we have to learn to not be afraid of. We want to understand that, especially in FIRST robotics, the whole point of this is not necessarily to have a perfect robot. It's to learn how to get better. And so by failing, we actually have a lot of opportunity to look at what we did and move forward, get better and improve ourselves. So when we acknowledge failure, we want to be really thoughtful about it in this context. If you miss your goals, be compassionate with each other. The point is not to be upset and be down on yourselves or on each other. You want to work to figure out what went wrong. You want to fix the problem moving forward and adjust the timeline if you need it. It's not the end of the world. It's just the end of that part of the project. And it means that you can now step forward and learn from it. The whole notion of iterative design centers around the idea that you aren't going to get it right on the first try, and you're not expected to. So keep that in mind as you go through. Make sure that you're learning from your mistakes. In order to do this, I highly recommend things like review meetings. Even if your robot is finished, take time to actually talk about what happened. This can be reviewing the robot. This should be anything that you would write down. This is a great time to write it so that estimations versus actual stuff, that's where we're going to talk about this. Communicate with each other. Use those effective communication strategies and add to your notes. This can be a review meeting about any of your goals as well. So it might be how the robot went, but it also might be, did you have fun and are people happy here? Make sure that you're assessing all of your goals when you're learning from your mistakes. On the right-hand side, my personal example of this again is my boyfriend and I joined the pandemic bread baking trend. And our first loaf on the left was, well, not exactly what I would call bakery quality. But we wrote down the formula, we wrote down the recipe and everything that we'd done, and week after week we tweaked it a little bit here and a little bit there, and eventually we got a much better loaf. But if we'd given up at the first one and said, guess this isn't for us, then we never would have had our delicious cinnamon swirl bread. So if you want cinnamon swirl bread, learn from your mistakes. That's what I recommend. The takeaways from this are, when you start out, make sure that you think through the whole project. It's okay to take a little bit of extra time to step back and look at what's happening, because it's really going to save you time later. Communicate and record your information. Understand that planning is only half of the problem, and you want to make sure that you're actually working together, working towards one goal, and sharing what you know, making sure that it sticks around and that it's helpful to you. And last but not least, review what happened so that you can do better next time. You want to make sure that this knowledge is going to be helpful for you, and that any mistakes and any failures and any successes can be moved into the future. You can use that and grow and learn. So thank you all so much. I've included my email and my LinkedIn tag here. I'm happy to take questions now. They can be about project management. They can be about what I do at my job at HighRes. I'm also a 2020 grad, so if anybody, especially in the US, has questions about college, has questions about what the robotics field is like right now, I'm also happy to talk about that kind of thing.
Thank you so much, Ms. Carey. That was awesome. Like she said, please feel free to type any questions into the chat, and we'll just wait a second to see if there are any of those. Okay, we have one from Phoenix Force. What FRC team were you on, and where was the team from?
Sure. So I'm actually from Massachusetts. I grew up in Burlington, Massachusetts, and at the time I was on team FRC, not FTC, team 2876. It was a bit of a chaotic process, and it was it was where I learned that you should grow from failure rather than accepting it as a bad thing and moving on. But it was really a great experience, and I really loved it there.
Yeah, thank you. And then one more question. If a team is not used to having organized project management, what is the first step?
To me, project management stems out of intuition. If you aren't used to organized project management, if you aren't in the state of mind to be having daily meetings and you don't want to go as far as like full agile scripted, here's what we're going to do every 5 minutes, think about the things that are most natural to you. Start with really big overall goals. Recognize where you're headed, what's comfortable. And at the end of the season, step back and say, did that get us where we needed to go? Does that answer the question?
Yes, thank you.